Before we can write code for our rover, we have to understand how the rover works. The rover has a built-in small computer that is running ROS. ROS stands for Robot Operating System. It is the brain of the robot. It is used all around the world and many types of robots support it. What is interesting for us is that we can write and test our code in a simulator and later run that same exact code on the real robot. If there is one thing to know about ROS, is how ROS messages work. The ROS messaging system is one of the most important components and allows all the different parts of the robot to work together. Look, a robot has many different parts, such as sensors, cameras, and motors. And all those parts have to work together. For example, if the sensor detects an obstacle, the motor should maybe drive backwards. Basically, all components need to communicate together. With ROS, this is done using the publish-subscribe pattern. Here's how it works. It's very simple. It is just like a radio station. You can tune or subscribe to a radio channel and you will hear this channel. Or if you are a radio, you can broadcast or publish data and others who subscribed will hear you. With ROS, every component has one or more topics that you can either subscribe to get some data or publish messages to send some commands. Let's take the rover for example. The motors of the rover subscribe to a topic to receive motor commands. So you can publish messages to that topic and order the motors to go forward. In addition, the rover motors publish motor-related data to another topic. This allows other components to know what the speed of the motors in real time is. Let's see an example. If you continue from the last video and you have both terminal tabs open and the simulation is running, then you can hit Ctrl plus Shift plus T to open a third tab. If that's not the case, just check the previous video. Now in the third tab, write ROS topic space list. Hit enter and you will see the list of all available topics on this rover. Each topic is basically one function. For example, the topic mavros/battery is a topic that you can subscribe to and get the battery level of the rover. Other topics like /rover/ground truth/pose or odometry or IMU will give you various information about the rover's position and orientation. Right now, with this list, we don't know yet how the topic works, what kind of information it sends out or needs. We need more information, and to do that, we type ROS topic info followed by the name of the topic. So, ROS topic info/rover/ground truth/pose. And now we see that there is one publisher and no subscribers. We also see that the type of messages for this topic is geometry messages. In the same terminal, we can subscribe to a topic and get the live data. You can type ROS topic echo /rover/ground truth/pose. Now you see that the values are constant since the rover is probably not moving. There's just a very small amount of noise in the data. Let's leave this running and come back later. Open a new tab, Ctrl Shift T. Now we will publish a message to make the rover move. Since we created a new tab, we first need to run the command source ~/simulation/roscatkin/ws/devel/setup.bash. We should also change the mode of the rover in order for it to accept those messages. So go to the first tab and type param set sysid mygcs and set it to 1. Let's head back to the latest tab that we created. Now, to publish a message that will make the rover move forward, we write ROS topic pub /mavros/rc/overwrite, and then the message type is mavros messages/overwrite rc in, and then quotes, channels, colons, and then square bracket, open, and then the value 1500, 0, 1800, and then you add 5 more zeros. And then you close the square bracket, and then you close the quote. The first value is a yaw and is used to turn the wheels. 1500 keeps the wheels straight. The third value is the throttle. That's how fast you want to go. Let's hit enter and this will tell the rover to move forward. You can check the previous tab and you should see the values changing in real time. We subscribed and now we get the data that the rover publishes there. I think you understand how this works. I let you play with it. Remember that 1500 is the value to stop. And with this, we are finally ready to move over to Python and write some real code. I will show you how to write a very simple controller logic for the rover. It will drive around and avoid obstacles as best as it can. See you soon.